Imagine a world where electricity flows without resistance, where computers operate at unprecedented speeds, where medical imaging becomes incredibly precise. Welcome to the world of quantum materials. These are not just materials, they're the key to unlocking new frontiers in technology, energy, and electronics. Their unique properties, shaped by the principles of quantum mechanics, open up extraordinary possibilities. So buckle up, as in the next few minutes we will journey through this fascinating realm of quantum materials. Quantum mechanics, the theory that describes the behavior of particles at the smallest scales, is the key to understanding quantum materials. Now let's unwrap the mystery of quantum mechanics a bit. Quantum mechanics is a fundamental theory in physics that explains the nature and behavior of matter and energy at the quantum level. That is, the scale of atoms and subatomic particles. It introduces concepts like superposition and entanglement. Superposition is the ability of a particle to be in multiple states at once, while entanglement is the phenomenon where particles become interconnected, with the state of one instantly affecting the other, no matter the distance. These concepts, as strange as they may seem, are at the heart of quantum materials. They give rise to properties that seem to defy our everyday understanding of the world. These principles create materials with extraordinary properties. Superconductors are materials that can conduct electricity without any resistance. Now you may be wondering, how is that even possible? Well, it's all thanks to the magic of quantum mechanics. When cooled to extremely low temperatures, superconductors allow electrons to form pairs, which move through the material without scattering off impurities or lattice vibrations. This is what gives rise to the phenomenon of zero electrical resistance. These materials are not just fascinating from a theoretical perspective. They have some very practical applications as well. Imagine electric grids that can transmit power without any loss, or super-fast maglev trains floating on tracks due to the Meissner effect, a unique property of superconductors. Even more excitingly, superconductors could play a key role in the development of quantum computers, which promise to perform calculations far beyond the reach of any conventional computer. So in a nutshell, superconductors could revolutionize energy transmission and storage. And that's just the tip of the quantum iceberg. Topological insulators are materials that behave as insulators in their interior but have conducting states on their surface. Now, isn't that intriguing? These unique materials are a whole new state of matter, and they're altering our understanding of physics as we know it. Imagine a material that can conduct electricity without any resistance, but only on its surface. Inside, it's a different story, where electricity cannot flow. This is the paradoxical world of topological insulators. The surface isn't just conducting, it's superconducting, meaning it can carry an electrical current indefinitely without losing any energy. Now think about the potential applications. With their distinctive properties, topological insulators could revolutionize technology, particularly in electronics. They could pave the way for faster, more efficient, and more stable electronic devices. And that's not all. They're also promising for quantum computing, a field that could completely reshape our digital world. Topological insulators could be key to next-generation electronic devices. Quantum dots are tiny particles that emit light of different colors depending on their size. Now, isn't that magical? But it's not magic, it's science. Quantum science, to be precise. These minuscule particles, also known as nanocrystals, are so small that they're affected by quantum mechanics, the rules that govern the very smallest particles in our universe. So, what's the big deal about these tiny dots? Well, their unique property of changing color depending on size opens up a world of potential applications. For instance, they could be used in creating more vibrant, energy-efficient displays for our devices, outshining traditional LED technology. But that's not all. Imagine a world where detecting diseases is as simple as shining a light. Quantum dots could make this a reality. By binding to certain molecules, these dots can illuminate specific cells or proteins, revolutionizing medical imaging and potentially leading to earlier detection of diseases. Quantum dots could transform lighting, display technologies, and medical imaging. Talk about a small particle making a big impact. Opening. The extraordinary properties of quantum materials are due to quantum phenomena such as superposition and entanglement. At the heart of quantum mechanics lies the principle of superposition. It is the idea that a quantum particle can exist in multiple states simultaneously, only deciding on a single state when observed. Imagine a coin that is both heads and tails at the same time, only choosing one when you look at it. This phenomenon is what gives quantum materials their unique properties. Take entanglement, for instance. This is the mind-boggling concept that two or more particles can become so deeply linked that the state of one instantly influences the state of the other, no matter the distance between them. This spooky action at a distance, as Einstein once called it, is another key to the magic of quantum materials. These principles of quantum mechanics, superposition and entanglement, are what allow quantum materials to exhibit extraordinary properties and behaviors. Closing. These phenomena make quantum materials unlike any other. Despite their potential, understanding and harnessing the properties of quantum materials is a formidable challenge. Quantum materials operate under the rules of quantum mechanics, a realm where particles can exist in multiple states at once, and properties can change depending on how we observe them. This inherent unpredictability makes studying these materials a complex task. Even the most advanced microscopes and instruments struggle to capture the fleeting and elusive quantum phenomena. And then there's the issue of temperature. Many quantum materials only exhibit their unique properties at extremely low temperatures, far colder than any natural environment on Earth, which poses an additional layer of difficulty in studying them. Simultaneously, understanding quantum materials requires an interdisciplinary approach, merging physics, chemistry, and material science, among others. But, as researchers continue to experiment and innovate, they are making strides in overcoming these challenges. But with every challenge comes an opportunity for discovery and innovation. The enigmatic world of quantum materials continues to enthrall and perplex, promising a future of untold possibilities. The future of quantum materials is incredibly exciting and holds promise for numerous applications. As we dive deeper into the quantum realm, we're constantly discovering new properties and potentials. Imagine superconductors with zero electrical resistance, powering our homes and cities with unprecedented efficiency. Picture topological insulators, directing the flow of electricity with surgical precision, redefining our electronic devices. Quantum dots, those magical nanoparticles, could lead to significant breakthroughs in solar energy conversion, medical imaging, and even quantum computing. And this is just the tip of the iceberg. As our understanding of these materials grows, so does our ability to harness and manipulate their unique properties. The implications? Staggering. We're talking about a seismic shift in fields as diverse as energy, technology, medicine, and more. However, as with any frontier, there are challenges and mysteries yet to be solved. But one thing is certain, quantum materials could reshape our understanding of the world and revolutionize technology. As we continue to explore the quantum world, we unlock new possibilities for our future. We've delved into the fascinating realm of quantum materials, where the principles of quantum mechanics give rise to extraordinary properties. We've discovered materials like superconductors, which exhibit zero resistance, and topological insulators, a new state of matter that conducts on the surface but insulates within. We've also explored quantum dots, the magic dots that hold great promise in technology and energy. These materials, each unique in their own right, showcase the astounding potential of the quantum realm. They're not just theoretical musings, they're tangible, promising, and on the brink of revolutionizing our world. From technology to energy to electronics, the applications are as vast as they are exciting. The quantum revolution is here, and it's changing the world as we know it. The world of quantum materials is as fascinating as it is complex, and we've only just scratched the surface. There's a whole universe of quantum wonder waiting for you to explore. Dive deeper, question more, and let the extraordinary properties of these materials fuel your curiosity. Remember, the key to unlocking the future lies in understanding the present. What quantum material intrigues you the most? How can their properties revolutionize our world? Share your thoughts in the comments below. Quantum materials are not just the stuff of high-tech laboratories and complex theories. They're here now, part of our everyday lives. You might not realize it, but you're likely benefiting from them already. Let's take a closer look. Quantum dots, those tiny particles we spoke about earlier, are used in television screens to enhance color and brightness. They're the reason your favorite shows look so vibrant and lifelike. Superconductors, materials that have zero resistance, are used in MRI machines for medical imaging. They're helping us peer inside the human body with unprecedented clarity, aiding in the diagnosis and treatment of a wide range of medical conditions. And the future? It's even more exciting. Quantum materials could soon be used in batteries, drastically improving energy storage and making our devices last longer. So, you see, quantum materials are closer to our daily lives than we might think. They're not just shaping the future, they're transforming the present, making our world brighter, clearer, and more efficient. Isn't it fascinating how these tiny particles have such a big impact? Quantum materials aren't just transforming our devices and medical technologies. They could also play a key role in addressing one of the most pressing issues of our time: environmental challenges. Let's imagine a world where power is transmitted without energy loss. Superconductors with their zero resistance could make this possible. This would drastically improve energy efficiency, reducing our carbon footprint and making our societies more sustainable. And what about harnessing the power of the sun? Quantum dots could be used to improve the efficiency of solar cells, capturing more of the sun's energy and converting it into electricity. This could revolutionize renewable energy, making it a more viable alternative to fossil fuels. But it doesn't stop there. Quantum materials could also help develop new, more efficient, and less polluting technologies, from water purification systems to air quality sensors. This truly is a game changer. Quantum materials could not only make our world more efficient and connected, but also cleaner and more sustainable. The future is bright, and it's powered by quantum materials. As we've seen, quantum materials have the potential to transform our world, but their reach extends far beyond our planet. Quantum materials could revolutionize space exploration. Superconductors, for instance, could be utilized in propulsion systems for spacecraft. Imagine a spaceship that can travel faster and further, using less energy, all thanks to the zero-resistance properties of superconductors. Quantum dots, on the other hand, could be used in sensors and imaging devices for space exploration. With their ability to absorb and emit light at different wavelengths, quantum dots could provide us with unprecedented images of distant planets and galaxies. And let's not forget survival. Quantum materials could help develop technologies for surviving in the harsh, unforgiving environments of space. From radiation shielding to energy-efficient life support systems, the possibilities are endless. The future of space exploration could be shaped by quantum materials. It's not just our world that's getting a quantum upgrade, the universe is too. As we continue to explore the potential of quantum materials, it's crucial to consider the ethical implications. Like any powerful technology, quantum materials could be misused, potentially leading to unforeseen consequences. For instance, quantum computing could be used to break encryption codes, jeopardizing our security and privacy. Moreover, with the rapid development of quantum technologies, there's a pressing need for regulations to guide their use. These regulations should ensure that quantum materials are used responsibly and for the benefit of all. They should also address issues of accessibility and fairness to prevent the creation of a quantum divide. Beyond that, we must also consider the societal and environmental impacts of quantum technologies. How will they affect our daily lives, our communities, our planet? What are the implications for resource consumption, waste generation, and climate change? As we embrace the quantum revolution, ethics should be at the forefront of our thoughts and actions. It's not enough to simply develop and use quantum materials. We must do so in a way that respects our ethical values and contributes to a sustainable and equitable future. As we reach the end of our exploration, it's clear that the world of quantum materials is full of potential and challenges. Their extraordinary properties, from zero resistance to the magic dots, open up a world of new possibilities. Yet, we have also seen that there are many hurdles to overcome in fully understanding and harnessing these fascinating materials. The ethics of quantum materials, the potential impacts on our daily lives, and the environment are all considerations we must take into account as we stride forward. Despite these challenges, the future of quantum materials is undoubtedly exciting. They hold the promise of revolutionizing numerous sectors, from computing and telecommunications to energy and space exploration. As we stand on the cusp of this new era, it's clear that the quantum revolution is just beginning. It's a journey that will require not just scientific and technological innovation, but also ethical and societal engagement. Together, let's embrace this quantum revolution, responsibly and ethically, and see where it takes us.